Hi, I'm Neethu, Assistant Professor, Department of Mechatronics, Nehru College of Engineering and Research Center, Pampadi. Today, we are going to discuss about the blood gas analyzer. So, blood gas analyzers is used to measure the pH, partial pressure of carbon dioxide, partial pressure of oxygen of the body fluid with special reference to human body. As we all know, in our body, the acid-base relationship should be maintained. Okay, the acid-base relationship should be maintained. For this, pH, partial pressure of carbon dioxide, partial pressure of oxygen should be maintained. Okay, or the sudden change in the pH and PCO2 will result in ventricular hypertension, cardiac arrhythmia, and it will cause even death also. So the maintenance of or maintaining the partial pressure of carbon dioxide, partial pressure of oxygen, and the pH is very important. For this purpose, we are using blood gas analyzer. Blood pH measurement. The acidity or alkalinity of the solution depends upon the concentration of hydrogen ions. That is, if the concentration of H plus ion is high or increasing, it is called as acid, or if it is less, it is called base. And pH is nothing but the measure of hydrogen ion concentration, and it is expressed as minus log of H plus. Okay, so for this, we just consider a glass electrode. The potential E of the glass electrode is represented as E is equal to E0 minus 2.3036 RT by F into delta PF. Okay, now we can explain the pH measurement. Okay, how we can measurement pH by using blood gas analyzer. Okay, so there are three measurements: pH measurement, PO2 measurement, and PCO2 measurement. First is pH measurement. This is the pH electrode, and this is a setup for measuring pH. Okay, for this, take the solution in a beaker, a pair of electrode, that is one glass or indicating electrode, and other is reference electrode or calomel electrode is immersed in the solution. The voltage developed across the electrode is applied to an electronic amplifier, which transmits the amplified signal to the display. Okay, in the figure shows that the glass electrode, okay, the pair of electrode, one is glass electrode and other is electrode or reference electrode or calomel electrode is used. The most common type of glass electrode used is syringe electrode because it is convenient for taking samples of blood, right? So, while we are using syringe electrode, the syringe should be rolled between the hands to ensure the thorough mixing. Micro glass electrodes are preferred when we are using the pH monitoring in the surgery and all. Okay, that is real-time monitoring. In the situation where real-time monitoring is required, we are using micro glass electrode. And the internal reference electrode is Ag bar AgCl, and calomel reference electrode is connected to a small pool of saturated KCl through a porous pin. Calibration with solution of known pH is performed before measurement of patient's specimen are made. And here, the internal reference electrode is Ag bar AgCl, and it is connected to a calomel reference electrode through a pool of saturated KCl. So, in this way, we can measure the pH of the blood. Okay, next is measurement of PCO2. Okay, measurement of PCO2. This is the construction setup for measurement of PCO2, and here the measurement of PCO2 is made based on the fact that the relationship between log PCO2 and pH is linear over the range of 10 to 90 mm of Hg. So there exists some fundamental relationship among H plus, H2CO3, HCO3 minus and PCO2. Here the first three quantities, that is H plus, H2CO3, HCO3 can be related as H2O plus CO2 gives H2CO3, that is carbonic acid. In turn it gives H plus plus HCO3 minus. Okay, take it as equation 1. The relation between PCO2 and CO2 dissolved in the blood is given by CO2 is equal to A into PCO2. Take it as A, equation A. The relationship corresponding to equation 1 can be written as K bar is equal to H plus HCO3 bar H2CO3. That is, H2CO3 is directly proportional to CO2. Mark it as equation 2. Therefore, K is equal to H plus HCO3 minus bar by CO2, where K represents the combined value of K bar and proportionality constant between H2CO3 and CO2. Or K can be represented as H plus HCO3 by APCO2. Mark it as equation 3. And taking log on both sides of equation 3, we get log H plus plus log HCO3 minus log K minus log A minus log PCO2. That is, using the definition of pH we know pH is equal to minus log of H plus. Therefore, pH is equal to log HCO3 minus log K minus log A minus log PCO2. Mark it as equation 4. And equation 4 represents that pH has a linear dependence on negative of log PCO2. Okay. Next comes the construction of PCO2 electrode. Okay, as shown in figure, the assembly includes two chambers, one for the specimen and second for containing a pH electrode. The pH electrode is placed in the specimen and pH electrode is bathed by a solution of NaCl. And the two solutions are separated by a semi-permeable membrane made up of Teflon coating, Teflon or silicone. This membrane allows dissolved CO2 to pass through but blocks the passage of H plus and HCO3 minus. When the specimen is placed in the chamber, CO2 diffuses across the membrane to establish the concentration in both chambers. If there is a net movement of CO2 in or out of the chamber, the pH meter indicates what? The pH meter indicates this change, and this change is noted. Okay. So next comes the measurement of PO2. This is the figure for measurement of PO2 electrode, and this is the construction of PO2 electrode. Partial pressure of oxygen in the blood or plasma indicates the extent of oxygen exchange between the lungs and the blood. That is, ability of the blood to diffuse the body tissue with oxygen. And the measurement of oxygen is done by using a polarographic electrode. And this electrode consists of what? This electrode consists of a platinum cathode, an Ag bar AgCl anode in an electrolytic filling solution, and a polypropylene membrane. And it also contains a reference electrode in its assembly. And the entire unit is separated from the solution under the measurement by a polypropylene membrane. The O2 from the blood diffuses across the membrane into an electrolytic filling solution and is reduced at the cathode. At anode, the silicon is oxidized and the magnitude of resulting current indicates the partial pressure of oxygen. And the cathode reaction can be explained as O2 plus 2H2O plus 4 electron gives 4 OH minus, and anode reaction is 4 Ag gives 4 Ac plus 4 electron. The polarizing voltage of about 600 to 800 millivolt is required for this reaction to occur. We can determine the value of PO2 by measuring the flow of current through the external circuit connecting the electrode that is proportional to PO2. When the PO2 level is 0, what happens? The current flows the circuit, and this current is called background current. The choice of the semi-permeable membrane is like the more permeable the membrane to O2, the higher the consumption of O2 and faster is the response. This is how the PO2 is measurement. So, in this blood gas analysis, this is one of the most important topics. In this blood gas analysis, we just mentioned the measurement of blood pH, measurement of partial pressure of oxygen, and the partial pressure of carbon dioxide. Okay. Thank you.